So seeing as I'm going to be away, I'm going to explain a little bit about electrochemistry. In particular, I'm going to talk about the thermodynamics of electrochemistry, which will include electrochemical potentials and the Nernst equation. And I'm also going to look at the kinetics of electrochemistry, which is quite an exciting link that you can now make between this thermodynamics and kinetics. And electrochemistry is one of the important fields that allows us to link together the energetics, thermodynamics, which answers the question, will it happen? And then also kinetics, which is how quickly will it happen? So firstly, just a bit of a reminder about electricity. The important kind of things about electricity are thinking about electric fields, right? And this is kind of like thermodynamics. So there's a certain energy that's involved in moving charges apart. But there is also a current that can be developed, and so that's the speed with which the electrons move. And these two things can be kind of thought of as kinetics in the case of current, because it's talking about the speed, and the electric field can be thought of kind of in a thermodynamic way. So we're thinking about energetics. And so the electric field is measured in volts, and the current is measured in current or milliamps usually. And so how these two link together, if there's a linear relationship, is through some resistance. Okay, so if I put a voltage over, say, a light bulb, then depending on what the resistance is of that light bulb will give us a current running through that light bulb. And so let's have an example here. A battery sets up an electric field inside of this wire, like so. So if I was to put a multimeter across here, we would read 3 volts. Okay, let's say it's a little pen battery or something like that. Now this is a copper wire, and so electrons will be provided from the negative end of the battery, and will fly up here. And basically this is usually something like a tungsten wire. And it has a larger resistance than the copper wire, which is what it's going through. Now the flow of those electrons get converted into vibrations in the lattice of the tungsten, and that converts the electron motion into heat, basically, and light. And so we have this relationship now between the voltage here and the speed at which electrons are going around here, which is the current. And so the equation is that the voltage is equal to the current times some sort of resistance. And so that's kind of one way of saying it. The other way of saying it is to kind of think about the opposite of resistance, so how well it conducts, which is conductance. And so we can also describe it in terms of conductance, which is sometimes what happens when you consider a solution. So we can think about one of your labs where you have to consider the conductance of some solutions, and you've got these 2 electrodes like that, and you've got some sort of ionic solution in here. And what you do is you're trying to measure the resistance so if you move electricity through the solution, what's the resistance for that motion? And so what that little device does in your lab is it applies a voltage, and it measures the current, and from that it can deduce the resistance, or equivalently the conductance, right, which is 1 over the resistance, vice versa. So there's some kind of basic chemistry, and you can start to see how we can think about these electric fields over here in terms of thermodynamics and the kinetics in terms of this current. So let's start off firstly with the thermodynamics of this. So let's say I've got some sort of electrode surface here, and let's go for copper, because that's the example in your book, and it's in contact with water where there is some dissolved oxygen in here. Okay, so what's going to happen is some surface chemistry is going to occur at the electrode surface. So what's going to happen is that the copper is going to be oxidized to copper 2+, so you'll have copper going to copper 2+, and you're going to have 4 electrons released. So that's going to be copper going into here, from here into here. It's going to go from copper to copper 2+. Now that is going to release an electron, and that's going to allow this oxygen to come onto the surface of this electrode and allow that oxygen to be reduced. So you're going to have oxygen plus H2O plus those electrons that it gains from the copper, and it's going to go over to 4OH minuses. So this surface chemistry is going to occur. Now what's going to happen is there's going to be some sort of voltage that is developed, because we've got this current flowing and we've got this surface chemistry, and so there's going to be a resistance to this process occurring, and so we've got some sort of current here, we've got some resistance which is determined by this surface chemistry, the desorption of these oxygens on and the copper, some sort of energetics there, and so we're going to be able to define a voltage that relates to this this reaction, and so we call this the electrode potential. So there's some sort of reaction occurring on that surface, and the electrode potential allows us to determine what the energetics of that are. So one of the problems with voltage is it's very arbitrary, in the sense that, I mean, you could have a 9-volt battery, for example, and if you connected another 9-volt battery here, and if you connected these up like that, then you'd actually measure 18 volts between these two here. But equivalently, you could choose this point here as your 0 volts, and so up here you'd have negative 9 volts and you'd have positive 9 volts. And so really where you choose your 0 volts is kind of arbitrary. And so what people have developed is a way of describing kind of like a standard electrode potential, and that allows you to compare different reactions. And so a common one to do is to bubble hydrogen on a platinum surface, and we just define define that as as kind of like our 0 point, and that's quite useful to do. So the next question is so the important thing to note is that you have some sort of electric field being developed between the electrode